So let's switch with the Predicting Media Interestingness task, which is the only one new task this year, and for which we benefit from a large number of organizers, as you can see. Before diving into the details of the task, I would like to emphasize some of the challenges that we have. For sure, the first one is that when you ask people, are these images interesting? Well, their first answer and question is, okay, but which is your definition of interestingness? So this is the first task that we had in the task to define the interestingness notion. And it was not that obvious because, as you may think, interestingness is something that is perceptual, but also highly semantic and of course, in some parts subjective. So what we decide is to derive the task from a use case that we have at Technicolor, which consists in helping professionals to illustrate VOD, a video on demand website. So we want to help them select the most interesting frames so that when they propose these frames and shots to a specific user, it will help him decide whether he is interested in watching the specific movie. So this is why we had two subtasks in this task, one based on image and the other one based on video. The first one on image can be defined as the following, given a first set of keyframes that come from a movie. Please automatically identify among these keyframes which of these are the most interesting for this specific movie. And for the video subtask, well, it's basically the same, but for the shots. So you have a set of shots and you have to extract those most interesting shots. So the task was a binary classification task. So people has to classify the frames and the shots into two different classes, interesting and not interesting. But they were also asked to provide some confidence values so that we can just evaluate them afterwards. So Dataset, we worked on Hollywood-like movie trailers because of the use case. And it was not real movies because we were not able to find Hollywood-like free-of-right movies. So what we did first was manually segment all these trailers into different shots. And from each of these shots, we extracted one keyframe. It was the middle keyframe, which results in, for the development set, as you can see, from 52 trailers that we had at the beginning. This is a total of a little more of 5,000 shots and 5,000 keyframes. And for the test set, it was coming from 26 trailers, resulting in a little more than 2,300 shots and 2,300 keyframes. As you can see, the dataset is somewhat unbalanced, as we have around 10% of interesting content in each of the datasets. And we were also providing some pre-computed content features. Some of them were low-level features, and we would like to thank our participants from the Fundan University that provided those features for us, and also some mid-level features, and then it's big thank to you, Hanli, because you are the one that computed the features. And manual annotations. So as what was done for the emotional task, we also were using a pair comparison protocol. You can see the UI that we were using here. So each time people has to decide when they were shown two different frames or two different videos, which one was the most interesting. These data was annotated by a little more than 300 people for video and 100 for image, coming from 30 countries. And again, well, thanks to all of you, because we were quite short. We were running out of time for this and resource. So I send you a request for most of you And a lot of you participated to help us to annotate to the annotation. Thank you. So from this pair comparison, what we did was aggregate this into having rankings. So it's one ranking for shots for one trailer, and one rankings for the images from one trailer. And from these rankings, we manually threshold them so that we have a binary classification. As for the required brands, so we have one for both subtasks, and globally it's exactly the same. You can use what you want from the content, but no external data. And external data is defined as the following. So it's no additional data sets that relate to interestingness. It's no pre-trained models that were trained on interestingness related data sets. And it's no additional metadata that is linked somehow to the contents that we were providing. So external data is not a pre-trained model that could have been trained on other data sets. For example, a memorability data set, or I don't know, whatever, ImageNet data set. So for the evaluation metric, we decided to go on with the mean average precision as knowing the use case that we have, it's more or less a retrieval task. So we thought mean average precision would be good. But we also were computing additional metrics for the participants. As for the test participation, so we were very proud to see that we had more than 30 registration for the task. And in the end, it was 12 teams that submitted results to our task. 9 submitted to both subtasks, and we had 2 teams on the image subtask and 1 on the video subtask. And here are the results. So it's 27 runs for the image subtask. So the main thing that we can say, having a look at those results, is that the range of map values is not that high. You have the baseline at the bottom in yellow, so it's .16, and the first best participant got .23. But still, it's still significant values, we think, as the task is in its first year. So for the video, as you can see, the range is even lower, even smaller for the values. And well, I will come back on the video on the video subtask afterward, because we think the data set might be the reason why we have so low value. So what did we learn? On the task itself, we had a question at the beginning, which is why we decided to have the same data set for the image and for the video subtasks. So the question was, is image interestingness related somehow to the video interestingness? So afterward, we tried to build some correlation between the different rankings that we've got from the annotations, and apparently image interestingness seems to be not correlated with video interestingness. Okay, so going on with the video dataset, as I was saying previously, we tried to have a look at the quality of the rankings that we got after the annotations. For the image dataset, it seems okay. Well, I mean that when you have a look at the rankings, obviously what you have at the top levels is more interesting than what you have at the tail of the rankings. But for the video dataset, it's not that obvious in the annotation. So what we think is that our annotation process was an iterative annotation process, so we think that maybe we didn't do enough iterations. So we are quite sure that in the future for next year, we will have to think a little more on this part to either have more people or choose another protocol in order to have a better annotation for the video dataset. And well, the fact that you have an overall low map value means that there is still room for improvement. But this is the first year. And on the participant system, well, what we could say is that we had mostly machine learning system, either a classic machine learning system or deep learning system, but we had also one rule-based system, and what is interesting is that it's our winner for the image subtask. So the best system was not using any machine learning stuff. And well, for multimodality, mostly people were using video, but some of them were also using audio, and we had one team using text. For the temporal modeling, which was for us something that we thought was really important, well, only a few teams did use the temporal evolution of the data. So this might be also something that could be studied better in the future. And mostly nobody used external data. So as a conclusion, simple system, at least for this year, did as well, or even better than sophisticated systems. And we still need to think about the dataset size that certainly penalized deep learning system, and also maybe the dataset unbalance, which was, well, the fact that the dataset was unbalanced was only considered by 2 participants. And this concludes my talk.